Good afternoon and welcome to the plenary session for this afternoon. We're very much looking forward to the plenary on community-based ontology development, lessons learned from the financial industry business ontology. Now this will be given by Eliza Kendall, followed by that will be a poster presentation on the common action by Ellie Young, and then the session summary of all of the sessions that have taken place today. To introduce our speaker, Eliza Kendall is a partner in Thematics Partners LLC and graduate level lecturer in computer science, focused on data management, data governance, knowledge representation, and decision systems. And her consulting practice includes business and information architecture, knowledge representation strategies and ontology design, development and training for clients in financial services, government, manufacturing, media, pharmaceutical, and retail domains. And she's been working projects on use of ontologies to drive natural language processing, machine learning, interoperability, and other knowledge graph-based applications. Eliza represents knowledge representation, ontology, information architecture, and data management concerns on very important groups such as the Object Management Group, the Architecture Board, their Architecture Board, and she's co-editor of the Ontology Definition Meta Model, and the Languages, Countries, and Codes standards, and it contributed to a number of international standards of ISO, W3C, OMG, and so on. And of course, the financial industry business ontology, which we'll hear about today, but also working in other areas such as the retail industry ontology, and is also working on the Industrial Ontology Foundry, or contributing to that in terms of the Oversight Board, and prior to her current role, also being founder and CEO of Sandpiper Software, an early entrant in the semantic web domain. She has a BSc in Mathematics and Computer Science from UCLA and a Master's in Linguistics from Stanford. So we're very much looking forward to this presentation and the lessons learned from the FIBO ontology development. Over to you.
Thank you so much. So I am going to jump right in. Some folks asked me to present a little bit of what we've done on FIBO and to see how that can apply to other community efforts like OntoCommons. And so I guess the first thing I'd like to share is that there's really not a lot of understanding around the difference between building application-based ontologies, building enterprise-level ontologies, and building what I'll call an industrial ontology, which might include FIBO, but also the Industrial Ontology Foundry, IOF, also the retail ontology effort going on at the OMG. These are all large-scale ontology development efforts attempting to develop common language, common abstractions, common terminology that can be used across playing partners, across regulatory agencies, as well as commercial entities for research purposes and other reasons. And so the features of an ontology that's intended for industrial sharing are really different than those used for enterprise data, or even more specifically for certain applications. And so there are different things that you need to keep in mind. There are challenges that you don't have with ontologies that you have complete control over at the enterprise level or at an application level. And so it's important to understand that the target is different, and that the work that you do to develop such an ontology needs to reflect that. So there are lots of different use cases for industry-level ontologies, ranging from regulatory work to shared customer data. There's a lot of work that's been going on for many years in healthcare, for example, where people are attempting to share patient clinical data across multiple providers, and yet at the same time protect the patient's rights to personal data, especially healthcare data. Other places where we're seeing that now in the retail domain, this retail industry ontology effort that's been going on for about 2 years is focused first on ontologies related to digital receipts and the fiscal exchange of information across providers. So, for example, any VAT tax information going from some retailer to the appropriate regulatory authorities. And that work is making some significant progress at OMG. And they have a lot of the same challenges that we have in manufacturing, but from a different perspective. Less of the data is scientific, more of the data is business oriented. Although there is some that involves mathematics and formulas and other things like that when you're talking about taxation. Other things that we've seen is that there is a tremendous need for sharing things like code lists and data models that you might also find useful in an enterprise framework or for applications, but the development tends to happen at the industrial level. Lots of controlled vocabularies have been developed by communities over the years. AgriVoc is a very large one. Others are things like ontologies for languages, countries, and codes that we've done at OMG. The standard industry codes in North America also. And people are doing the same thing with similar standards in Europe. There are also a number of shared data sets, some of which are being published on data.world, as some of you know. The GLIFE, or Global LEI Foundation, has published close to 2 million, if not more than 2 million, legal entity records as one example. KEBI in the healthcare, and there are many others. So these kinds of efforts take on a different shape than your typical industry ontology. So suppose now that you're a company, the company is a stockbroker, they keep records of transactions, and so you have data in various fields and databases, and you can draw certain conclusions from that data within the company and using applications the company has built. On the government side, they care about things such as ownership of stocks and other legal or financial instruments, who owes tax on them, what kinds of bad behaviors do they want to be looking out for, and so forth. And the representation is likely different. The perspective is likely different from that of the stockbroker. And so the question is, how do we, building out industry ontologies, support them, and what is our role in doing that? We can't really choose between one or the other representation. In fact, the goal is actually to create some sort of a reference model that both can use, both can map to, both can align with, and to show them how these models relate to one another. And so that's really the role of an industry ontology more than anything else. And how do we do that? Well, it's hard, right? The first thing is you need to kind of have an idea of what the industry models should look like, combine features that we see in multiple models that either are contributed to the work or that we believe should be contributed to the work, and design some sort of a model that covers all of those features. And then with respect to what is shared in various sort of vertical domains across that industry, ensure that the core elements are consistent across those domains, which is really, really difficult. And then we need to be able to evaluate that model against real world data and situations that are fairly broad in order to ensure that we're meeting our goals. Okay. So a little bit about FIBO. FIBO has been around since roughly 2008, 2009 is when some of the work was initiated in developing it. It's an industry level ontology. It provides terminology and relationships and logic for reconciling language across financial players, including information about financial instruments, business entities, and relationships between them. It was originally a UML model and a number of spreadsheets with terminology in them that were transformed to OWL in 2013. And we have, over the years, put more and more robust features into our infrastructure and development framework, and also into the policies and procedures we implement in order to ensure consistency, in order to meet our clients' needs in terms of their quality requirements and so on. So that evolution led to a publication at OMG of an early version of the standard. We will be updating that in the coming months. And on the EDM Council site, we have quarterly releases regularly. The work now has a variety of domain experts and guidance from professional ontologists. It's published on the council website. It's freely available in GitHub. And any of you are welcome to download it and take a look. So the underlying infrastructure was one of the early wins. It was something that was really important for us. We built it out because there were multiple groups trying to coordinate across their efforts all at the same time. And without a common platform, that was really, really difficult to do. And so on the left-hand side here, there is some process work. There are team leaders and team members and an ontologist associated with each group of people that's developing out some domain area. We use Confluence for meeting notes and for publishing working documents and that sort of thing. The ontologies themselves, we manage in GitHub. We've added some code to support the linkage between GitHub and Jira, so we can raise issues and add details in Jira, including the linkage to Confluence. And then when we upload changes, they are automatically put through a series of tests through a Jenkins job that runs automatically in the background to ensure that everything that's published meets our minimal requirements. And so that whole set of infrastructure, there's also publication to the council's website. But the more important thing from a community development perspective is that it's all automatic. It's all open source. It's available on the EDM Council's GitHub for anybody that's interested in downloading and reusing it or customizing it. It's all driven by Sparkle queries in terms of the testing that we do. And so we've been adding more and more tests over time. I think they're adding a new one this week, in fact. So the bottom line is that this evolving infrastructure for continuous development has been a big win for us, and it's helped facilitate not only better quality in the results, but be a place where people can come and raise issues or ask questions. And there's a whole process around how we do that. And the actual ontology development approach has changed over time in addition to the infrastructure. So it started out as a very large UML model. There were groups of up to 60 people on a single phone call who would participate in reviewing various parts of the model. And in those circumstances, often only the loudest voices are heard, and a lot of people feel somewhat disenfranchised. And so even though they made some progress, it wasn't ideal. And so once it was transformed to OWL and refactored into domain areas, we broke up the groups into smaller teams. Each of those teams works with an ontologist to sort of re-architect or continue to evolve a given domain area. And then we, over time, put together policies with respect to anything needed to make the changes consistent. So common URIs and common naming conventions and common metadata requirements and common approaches using ISO 704 for your natural language definitions, and agreement on the kinds of constraints we would or would not include. Agreement on things like, even though it's a very large ontology, and even though OWL doesn't necessarily enforce it, we agreed to a unique labels convention so that we don't have duplication across the model, at least in the released content. That's not true for anything that's provisional or in flight, but for anything we release and claim is released, we have a unique label assumption. And then increasing automation with respect to how we serialize the ontologies, unit level testing, and some integration level testing. And we've been adding reference data over time and more examples to help increase the quality as well. But FIBO is pretty large, so issues still come up from time to time. We are still addressing consistency across some of the domain areas and inside some of those areas. I think it's a never-ending task, actually. And then one of the things that happened over the last 2 to 3 years was really increasing the focus so that we could be more productive. So we paused development for about 6 months to build out a series of focused use cases in each domain area, including a number of different scenarios and competency questions for each area. Not necessarily the foundational content, but for any of the specific topics like securities or derivatives or something else, so that we would focus our development on those use cases rather than on anything about financial instruments, which was where we were previously. So the work now is organized mainly by use case for each working group, but we do have ad hoc bug fixes from time to time when things come up. And issues are raised in GitHub by anybody using or downloading FIBO, or in Jira by our working groups and other EDM council members, or during working sessions, and we capture them in minutes. Team members work together during the sessions, especially in areas that need work or that are new, talk about the changes, agree on the approach to addressing them. And then several of us will continue the work offline between meetings. We present revisions at the following meeting, or if they're really small, we just create a GitHub pull request and people review that offline. So our issue resolution process, which is something that isn't in place yet for the IOF, every change runs through what we call the RDF serializer that's available freely and open source at the link in the slide, which allows us to continuously serialize RDF XML or Turtle or JSON LD the same way so that you can compare the changes visually in GitHub. So that's become very important with us. We also occasionally use tools like Robot from the OBO Foundry to do diffs on the axioms. But for a GitHub comparison, having the serialization be consistent is really important. And then every change has to conform with our guidelines. We've published and continue to evolve those guidelines. They need to conform to our policies, and they need to be provably logically consistent, and they have to pass all the automated tests I already mentioned. And then there's a final approval process. So once everything is passed, that doesn't mean it's good to go. We have at least 2 reviewers that look at every pull request before they are merged. The ontologist doesn't have permission to merge them, in fact. So that makes it take a little bit longer at times, but really worthwhile. The publication process also runs with every pull request for latest versions. Every release is published quarterly with release notes, version IRIs corresponding to the quarterly release. Releases are tagged in GitHub. We generate the release notes out of GitHub and then summarize them by domain area. Now, and as I said, it's still quite complicated. So our latest innovations involve simplification based on common patterns. So I've been asked the question a lot, especially by IOF folks, don't you use a top-level ontology? And the answer is, well, no, but we do have a number of common patterns that we follow. And some of those are things like, to the degree possible, things rather than strings. We have sort of approaches for assigning names to things. Name resolution in big companies is a huge deal, very difficult to do. And so we have an approach to how we name people, organizations, and other things that seems to be working for us. Also, an identity pattern for identifying things. We have a pattern for relating codes to things, relating classification schemes to things such as financial asset classes, and so forth. And so I'm going to walk through a few of those and hopefully this will start to make sense. And I may not have time to run through all of them, but at least to give you a little bit of a flavor. So for naming conventions, a lot of people in their databases have, given name, middle name, or middle initial, surname, suffix, prior name, full legal name, all of these things in different columns in their database. But modern naming would say, well, not everybody has a first name. If you live in certain places in the world, you might only have one name. Some people have multiple hyphenated things added to their surname. Which one is the surname? Not clear. Are we going to disenfranchise somebody if we say they have to have each of these things? Are certain suffixes repeated? What's the pattern that works for naming of people, businesses, and other things without being culturally insensitive, and that it would allow us to do other things like create names and other identity information around digital footprints for a much more modern approach? And so what we have is a pattern. Inside that pattern, there's this notion of a structured name, which typically for a human being includes their full name, whatever form that takes, as a single value, and potentially a surname or family name for sorting, and any prefix that they need. And we're using a similar pattern for organizations. Around that structured name, we might have a representation of the period for which that name was applicable based on validation that we have done, the contexts in which an organization or person uses that name, the source that we use to validate that name, and then we use properties to relate back to a single instance of the person to say what is their legal name, what is their familiar name, what is their sorting name, and each of these has this little contextual framework associated with it. And that allows us to normalize names across a number of resources, contexts, and other things like that. Similar for identification. Identifiers are take a myriad of formats. Some of them are structured. Some of them include other identifiers. Most often they're registered with some authority. They're defined based on some scheme. And so the details about the identifier are again structured, including the scheme that's associated with them. They may apply for some window of time or have been validated for a window of time. They're used in some context. There's some source for confirming that. And the primary direction for naming, for identification that we use with respect to these properties is the identifier identifies the human being or the organization. And we only use the inverse is identified by, primarily in reasoning and in Sparkle queries, but also in cases where a name is intrinsic or an identifier is intrinsic to something, like an identifier for a financial instrument is intrinsic to that instrument when you create the instrument. But that's not true for organizations or people or other things. So we have to be very careful about when we use the inverse. So here's an example. This is an example for Citibank National Association. This is their legal entity identifier in the Global LEI reference data, which is available on the Glyph website or from data.world. Banks and regulators require these identifiers to identify counterparties to financial contracts. The search on the Global LEI Foundation is powered by ontologies that were inspired by FIBO and enhanced and evolved to support the Glyph process. Data for at least the last count of 1.9 and maybe over 2 million now records is available on data.world for these identifiers using the Glyph ontologies. So here's an example, the same identifier. So you have the LEI, it has information about it that includes the structure, the applicable period, the context in which it's used, the source for confirmation. There's a string value associated with that identifier, and it identifies Citibank National Association. There are more complicated patterns we have to deal with in finance, though. So associating parties with the roles that they play, identifiers associated with roles versus parties, and then broader situational analysis, which some people call reified relations, that links parties and roles to some patterns that are time bound. And many of these are important for finance. Some of them are also important for manufacturing, especially for supply chain analyses. So when is something a party? When is it a role? So a person is a party in our view. A legal entity is an organization, is a party in our view. A regulatory agency is a role that an organization can play. A financial institution is also a role that an organization can play. And so then from there, we try to tease out what the identifier or name is associated with. So with respect to a legal entity identifier, that identifies the legal entity. Whereas in the United States, an FDIC certificate, which is this little box you see on the right here, identifies specifically a depository institution, which is a role that an organization can play. And so there are lots of different identifiers that apply to a function that a bank or depository institution plays. Lots of identifiers that apply to the legal entity, teasing out which is which and putting the identifier on the role versus the legal entity is really important in order to truly identify who is who. The issues with respect to counterparties to financial instruments are really broad, very difficult to solve without this pattern. And in fact, a number of banks, at least in the US, that are globally important, have gazillions of legal entities. I think at last count, JP Morgan Chase had over 6,500 legal entities, because every time they create a new fund or create a new other kind of instrument they want to sell, they create a new entity in order to do that. And so rolling up risk is very difficult, and understanding how to identify who is critical. Another thing that I want to just mention briefly has to do with what I'll call situations or relationships that are essentially reified relationships. And examples include ownership, control, possession of something like a financial instrument, which you may have borrowed, so that doesn't necessarily imply ownership, affiliation, board membership, employment. All of those things are really situations that hold for some period of time. And doing proper analysis of those situations allows us to follow the breadcrumbs and understand who owns who, and to roll up risk for finance. And so this is a critical insight we found. We were able to test it with over 5 million records of data for one bank in particular, and found that it worked beautifully for that. And you can use these same patterns in finance to identify front running, insider trading, wash trading, a number of other potential issues that come up. And as I mentioned, to roll up risk to avoid the kinds of losses that Credit Suisse had early this year, and others, because Archegos Capital imploded. And so it also, these same patterns help us explain the results we're getting from some complex learning algorithms and other analytics. So just an idea about ownership. So for banks, you've got a holding company and you have various financial institutions, right? The holding company is the owner, and they own some asset, which might be a financial institution, might be a fund, might be something else. And ownership has evidence, typically a contract, but there may be more than that. So our basic sort of reified situation was inspired not only by the typical agent and agent role pattern, but by linguistics. And so here you see the situation holds for some period of time. You have actors that are the role, parties that are the direct person or organization that act in that situation. And then you have undergoers, which might either be another party or some asset in the situation. And we have pairs of properties that represent these things that are inverses of one another. And then we extend that pattern with a series of property chains that allow us to start from some point in the pattern and pull at the thread at the edge of the sweater to find the other players. So for instance, has active party is the property chain from has actor in the situation to who that role is played by. And so these are all chains, and they're pairs of chains. So has active party is the inverse of plays active role in. Is experienced by, pointing to the undergoer, is the inverse of experiences. And again, those patterns are really, really useful if you have the role or you have the party and you're trying to tease out who they're related to. Then we can also go from role to role. And we have similar property chains that say, okay, this actor acts in this situation, and that situation has an undergoer. So the actor effectively acts on the undergoer and vice versa. And so you've got, again, pairs of inverses. And here, from party to party with respect to the role, we do the same thing. And finally, we can go all the way around the mulberry bush through the situation to create chains that have multiple properties participating in them. So this plays active role that directly affects is a property chain that goes from the party to the role that they play in the situation, to the situation they're acting in, to the undergoer in the situation, and all the way back to the thing that they're acting on. And so that around the mulberry bush property chain is what allows us to connect all of the dots. And so for ownership, why is it so complicated? Well, it might be partial. It might be shared among parties. It requires evidence. It may be beneficial through a broker or custodian for certain kinds of securities. Corporate ownership structures are layered through subsidiaries. And combining identity resolution with this pattern is critical to understanding exposure across financial instruments. There is no way to do that cleanly and really efficiently without a pattern like this. And so we are taking these patterns and we're going back over FIBO to make sure that what we have, which typically was part of the pattern, completes the pattern and doesn't include any outliers that are not subproperties of the pattern. And so that process is taking some time, but it's cleaning up the ontology. It's allowing us to provide instruction to our users so that they actually recognize the pattern and can reuse it, and so forth. And so here's the example. I'm not going to go through this ad nauseum. You can do that on your own, but here's in Protege, the property chain for has owned entity, which is a subproperty of an active party. Has owning entity is a subproperty of is experienced by, and that chain, again, is what we use in order to identify who owns who. Here it is for the Citibank National Association ownership role, and you can see that we can add the percent ownership that its owner has. And then when we run the reasoner over a body of evidence in the ontology, not only can we see who is the direct owner, we can also infer who is the majority owner that owns the intermediary subsidiary. So that's all here for you all to look at when you have time. Just a quick summary of what we're doing now. Many of the patterns that we've been using and some of the ones that are in these slides have been validated via research with FIBO users over their very real data. Ongoing work, as I mentioned, includes building out domain areas that are incomplete, but also backfilling with these patterns to ensure consistency, eliminate cases that use anti-patterns where we need to, educating our user community about these patterns, which makes it easier for them to understand and extend FIBO. And then just one last point, we've been asked from time to time about folks in this community, why we don't use a traditional upper level ontology for FIBO. And there are a variety of reasons. Everybody has a different view on it, but some of them include that they make commitments that some of our users don't want. The language tends to be difficult for some of our users to understand, making it even more difficult for them to understand and extend FIBO. But this doesn't mean that we don't actually use them under the hood and map to them to do testing to ensure that we're still logically consistent. And I've done that with BFO a number of times. Every time we redo certain structures in the ontology, I've actually run it against BFO in the background. We just don't publish it with those connections to BFO. What we publish is what I'll call a decoupled version of the ontology without that mapping. And that gives our users something that easier to use, but at the same time, we can still test that we're consistent with it. And the other thing I would mention is that some of the patterns that we're using, especially with respect to parties and roles, align pretty well with those same upper level ontologies, as you might guess. So that's it for me.
Thank you very much. Thank you. Thank you very much. It's a really amazing effort, and I'd love to discuss it more, but we were a bit out of time. Okay. I mean, and I don't see Q&A at the moment. Will you be able to maybe join people in the lounge? There are little tables, virtual tables afterwards when you leave the session. So maybe.
Yeah, I certainly can. If you send me the link, I'd be happy to do that.
Basically, when you leave the session, you get straight into the lounge area, so you'll see that. Okay. The other, I mean, just one question, maybe just on a very high level. I mean, can you give any sort of indication about the resources that have gone into the development over the years? You know, there must be many person years.
Yeah. I honestly don't know. I know that from the council's perspective, they've pumped several $1 million into it, more than 5, which includes, the cost of the infrastructure, paying some people that are on staff, and so on, although most of the domain experts have been volunteers. And the support for that has come from membership dues primarily. And now they're building out a lab, an open knowledge graph laboratory that some council members, and other very large companies are in the process of standing up so that we could do specific use cases, not just on FIBO, but more on knowledge graphs generally. And they're also sort of getting into automotive now. And so there are other things that the council is doing, but for FIBO particularly, I believe there are some proof of concepts coming early next year with very big players that are now interested in using it, because it's evolved to the point where certain parts of it are quite stable, and people are finding it valuable.
I mean, that sort of experience, I mean, not just that, okay, there was a wow reaction, or maybe some jealousy from some communities about that, but also, I think it would be very useful, to understand what is needed, but then also what can be achieved with that and how that can be achieved. I know you already gave us a lot of that, but hopefully we and others in the community can stay in touch and discuss that.
Absolutely, and I'm happy to take questions via email or set up other discussions as needed.
But unfortunately, we need to move on now in the to be fair to others. And thank you very much again for your presentation.
You're welcome.
I believe we have now as a next speaker a poster presentation by Ellie Young. Is Ellie coming onto the stage?
Gerardelli seems to have some problem.
We're moving, or are we moving to the summary session first?
Okay, yeah, just before, just please. Yes, I was saying before we move to the session, even though Ellie is having problem in joining, you can find her poster outside of this session. Once the summary is over, there is a booth tab, and you can find her poster there. It's called Common Action. And I give the floor back to you, Gerard. Thank you.
Yeah, I'd just like to, I mean, even if there are technical issues there, give a little bit of a stage to that contribution. I will just read out the bio because I think it's an important work, also very topical. Ellie Young is founder of Common Action, and that is an innovation network facilitating climate and sustainability action through the development of community and knowledge graph technology. So that Common Action is working to build public collective knowledge graphs, enabling decentralized reporting of environmental, social, and economic conditions related to sustainability, as well as connections between companies, nonprofits, academics, entrepreneurs, and let me just see, and I can also, while I'm reading that, share that screen with you on that. So both of these efforts are designed to produce a coherent collective force across society for responding to urgent global priorities. And before founding Common Action, Ellie served as head of community and director of conference operations at the Knowledge Graph Conference. And to support the development of the global semantic community, she launched the Knowledge Graph Conference public Slack and a number of events, including the Knowledge KGC Book Club series and Knowledge Espresso video podcast. So all very interesting. And over a year, the Slack grew to over 2,000 members. Generally, Ellie's background is in sustainability with special focus in renewable energy, sustainable agriculture, and change strategy. And please also then join that and have a look at the poster in the poster booth, which you see in the when you go back to the reception area. So unless we now have Ellie back here, I would then, if that is not the case, I would then move on to the summary session. So I will just share the screen with a few slides about that, and then we will also have some speakers on this. So we had today 4 sessions in the morning: fair technology adoption and demonstrators, and the domain ontology for manufacturing and supply chain sessions, and in the afternoon, onto commons demonstrators and industrial engineering sessions. And since they are, as you see from the numbering, in kind of thematically had 2 streams, it'd be really great if we could now, have first of all the sort of number 3 labeled sessions, i.e. the domain ontology for manufacturing and supply chains, and then after that the industrial engineering summary. So the first one would be given by Arko Sarkar from Init on the domain ontology for manufacturing and supply chain. Arko, are you available to give us an overview of that? Or do you have any now? Ellie, if you're on stage, we can postpone the summary and give you the word.
Sure. Yeah, I think I'm a little bit early, but
yeah, we had some changes, but now we have you here. We might as well go for it.
Okay.
And yeah, okay, go ahead. I'll mute myself and give you the floor, please.
Great. And I suppose I will just share my poster.
Yes. Yeah.
Okay.
Yeah. Yeah, I gave you may not have heard it. I did a little bio for you before you joined, and we are now looking forward to your poster. Thank you very much.
Great, thank you so much. And I'll just assume that I still have 5 minutes, although maybe if I have 7, that'd be even better.
Go ahead.
Okay, great. Thanks a lot. I'm Ellie Young. I am the founder of Common Action, and some of you may know that I'm also the previous head of community at the Knowledge Graph Conference. So hopefully my co-author will be able to join, Dr. Adlira Kalemi, but if not, then, sort of maybe be able to speak later on. So we put together a poster on the core ontology for sustainable resource accounting. And the idea behind this is really to afford some assistance with semantic technology to industry, which bears the onus right now for transitioning from typical resource use towards more sustainable initiatives. So what we recognize is that society is, of course, increasingly recognizing the need for more sustainability around natural and man-made resources. But industry, really, as the bulk user of resources, has to be the one to make those changes. Nonetheless, there's not really a lot of domain expertise yet in the area to do this. It's a new topic. It's sort of a challenge to change historical standard operating procedures at a global scale. So the ESG market is currently sort of trying to address this challenge by helping companies report their various resource usages with different metrics. The challenge there, which we in the sort of semantic tech community understand, is that there are a multiplicity of these frameworks, and there's really a challenge around convening on the standard resources that need to be measured and how they need to be measured and by what data they are being measured. So it's a little bit of a Wild West right now. There's company reporting that's coming out, and this is not standardized. It's completely voluntary. There's web scraping that major databases are doing to get their information. So and the focus of all of this too is really about reporting and helping investors make decisions between companies as to who gets cheaper financing. The point is not as much about actions or what we can do to transform the resource use in our economy. So we want to address this problem, both the problem of standardization around measurement and the movement towards action, by bringing an ontology that actually measures all of the resources that need to be sort of identified throughout multiple stages of economic production. So, for example, if we think about the economy in a macro context, there are certain resources that are produced in bulk, and they're either extracted or they are extracted in bulk, and then they're either distributed for direct use or they're produced into another material. And there's a finite volume of those resources, like wood and metal and energy, of course, water, these kinds of things. What we imagine is an ontology that captures all of those pieces of those types of resources, as well as manufacturing activities, which have their own various footprints, and is available for various processing facilities to say, we use these materials in this quantity and in this number of steps. Together, this would allow for a sort of a snapshot of the total amount of resources used throughout the economy, and also for a macro level sort of picture, and also identify where the higher usage elements are. So what industries, what companies, things like this, what kinds of products. So there's 3 primary benefits to being able to see this macro level picture, which we detail in the poster if you're interested for kind of the breakdown. So the main one is, of course, decision support for companies, governments, investors, et cetera. If you could see what is actually happening, we can all kind of recognize where resources need to be directed. And this dovetails exactly into the next point, which is that with the identification of high usage companies and industries, we can also identify what the priorities are and communicate these and I'm just getting an internet. I hope that everyone can still see and hear me. Is it okay? I'll just keep going. So we Yes. So we want to enable the high view so that everyone can sort of converge on the same problem pane. And then we also want to identify where reduction targets, innovation targets, transformation need to be focused around, of course, high priority use areas. And the third piece of this is that this would also enable collaboration with cross industry and cross and beyond partnerships. So for example, in the automotive industry in Europe, competitors are now meeting to actually work together to create higher level standards around electrical vehicles rapidly. This is sort of something that is happening informally. What we would like to do is provide a backbone for this kind of collaboration with a shared language around the topics, and also open that up beyond a specific industry, say to the academics, the government, the entrepreneurs who are also interested in pursuing whatever initiatives they have available to support the same goals. So it's worth pointing out also that because sustainability and resource use are a universal concern, this ontology could serve as a backbone for an initial semantic framework for any given company. So, they could use this to at first just sort of capture their resource use, but then also add further additional domain specific concepts and build out more of whatever kind of tooling they like for Industry 5.0. So this is what we hope to build. If anyone is interested to provide expertise or partner in any other way, please feel free to reach out. I'm on LinkedIn at Ellie Young, and also available by email at ellie@common-action.org.
Thank you very much for your presentation. I can't see at the moment any questions, and also in the interest of time, I think we should probably move on.
Sure.
But are you going to be available in the at the poster booth or somewhere?
Yes. Is this in the lounge area?
There's a lounge area, yeah, and also there's a poster booth area.
Yes,
So
I will make my way over there.
Oh, yes, exactly. People can connect with you over there. Yeah, thank you very much.
Thank you.
So we still got your screen sharing on, I think. Yeah, now we're back here. Okay, thank you, Ellie, for that presentation. Hang on, there's yeah.
And I'm just trying to find how to exit the stage and get to the lounge.
Yeah, that's right. I think Luigi also will help you with that in a minute.
Great, thank you.
Okay, thank you very much. So back to when we're now going back to the session summaries, and as I introduced earlier, we had the 4 sessions, and we would like to then first of all start with the summaries of sessions 3.3, and then followed by sessions on the industrial engineering. So that will be Arco and Emilio. So do we have? Can we invite them to the stage, please?
Okay, hello. Can you hear me?
Yes, yeah, please go ahead.
Let me share my screen. Now I think I have to make it full screen first. Okay. Okay. Wonderful. I think everybody can see my screen. So very quickly, it was a morning session today on domain ontology for manufacturing and supply chain. And the objective were to focus on 3 areas. One is industrial maintenance, and then systems engineering, and also supply chain. So we had 3 speakers from different parts of the world. Melinda Hodgkins from Australia, University of Western Australia, Jinji Lu from EPFL, Switzerland, and Farhad Ameri from Texas State University, USA. So we covered all the time zones, and then I will move to the first talk, which was given by Melinda very quickly. She described her work on using ontology in the maintenance domain. So one of the most critical effort were to actually mine lot of unstructured and semi-structured maintenance work order and then annotate them and then gain some insight from them by using reasoner, and also feed this inferences into some machine learning model to gain much more insight from them. And she also showed some modular ontologies being developed for this purpose or already developed, and which adopts BFO ISO 19526 as top level ontology. And then she also showed a demonstration from an engine replacement use case where the system can automatically infer that the engine participated in an end-of-life activity from the maintenance work order. Okay, then the next talk was given by Jinji Lu from EPFL, Switzerland, about the systems engineering, where he first described how this new concept of model-based systems engineering is very critical in the, for the entire industrial engineering perhaps, and it can actually take a center place because, of course, it is being used by various areas of industry and engineering, but also in last 5 years there are a large number of publication on both MBSE and of course also using ontology for MBSE. So his work is also using ontology to define the system models, which are actually consisted of abstract concept, physical system, and the syntax. And the most critical problem in this area to how to model the abstract concept and physical system, and also have an integration between these two very different type of entities. He also mentioned about his involvement in the Industrial Ontology Foundry effort, and where he's trying to collaborate with other experts to make two ontologies, one for systems engineering general field, another is for MBSE. And also he showed some example and some demonstration from a software called Metagraph 2.0. And the third talk was given by Farhad Ameri, is from Texas State University, on supply chain ontology, which is also interestingly from his effort in the Industrial Ontology Foundry. Where he showed that this supply chain reference ontology is being developed based on different use cases, but from that demand that supply chain ontology is not only required by the supply chain domain, but many different business applications, especially ERP softwares, use supply chain as their module. So we need a supply chain reference ontology for interoperability. And he also showed a modularization model, which is very interesting. He referred as solar model. So if you are interested, you can go back and then take a look. He also had a demonstration from this agro-food use case for supply chain traceability. However, the most interesting part was the panel discussion, where because it went a little bit longer, because all the speakers respected their time, and so there were intensive conversation on various topics. There is no time to discuss all of them. So I will just mention about some of the questions which were discussed. So they were from industrial maintenance, how industrial maintenance can integrate different viewpoint. What is the rationale behind considering systems engineering as a kind of core reference ontology? What are the challenges in developing supply chain? But also the audience discussed on the use of digital twin in this type of ontology effort, or is there any sort of utility of digital twin technology? Also, we discussed about the machine learning and the ontology. How these two different type of AI technologies can come together for manufacturing domain. There was some discussion on whether we adopt the pluralism in the industrial domain, and can ontology actually substitute the standards, the industrial standards, in the future. So it is a very intensive discussion. I will encourage that everybody should go back and try to rewatch if you are interested into the industrial engineering topic. What are the key takeaway points? First of all, from the maintenance domain, it is very useful to use the semantic model to apply reasoning and to find root cause for some failure or degradation, and also the state of the system from the hidden knowledge which you can find in the maintenance work order. In the systems engineering, it is states that ontologies need to adopt a kind of system thinking, which is specifically from the system engineering practice. And then for supply chain, it is, as I said, it can contribute to the interoperability of many business application, from the ERP suite. And also, couple of more points from the discussion, that digital twin is a very recent and current technology which is gaining a lot of popularity. But the ontology engineering in this industrial domain already has the digital twin fundamentals embedded in the effort. And from the discussion, we learned that replacing the current industrial standards with ontology is a very big demand. Maybe it is not possible, but then ontology may help in annotating and digitizing the current industrial standards, which may be very helpful for collaboration.
Thank you. Thank you very much.
Thank you.
Thank you, Arco. And we'll now come to the next session, which will be summarized by Emilius and Filippo.
Yes, yeah, I am. Can you hear me?
Yes, thank you.
I will share the screen. I'm sorry, but the browser doesn't allow me to share the screen. Maybe you can just give me a second. I'm sorry, I cannot share the screen. I should close the application and reopen it, because this is the first time I'm using AirMeet. Maybe someone can share the slide I sent per email, like in the backstage.
We can also do that.
Otherwise,
yeah.
I just quit. Yeah, maybe Luigi has the slides.
Or if you we could also go to the next summary first.
Otherwise, Gerard, I can share the slide. Just 1 second. Let me retrieve them.
Yeah, thank you.
Just 1 moment, and okay, I'm turning the slide into a PDF, so it's readable by the platform. 1 moment. Okay, I should be able to share them now. I'm opening them now. Let's see.
Okay, here we are. I mean, you can just go to the final bullet points. Go ahead. Yeah, go ahead. Okay, here we have. Okay, thank you very much. Sorry about that. So we had in the session about industrial engineering 3 very interesting talks from both a theoretical point of view and also practical engineering.
Oh, now we lost the connection to Emilio.
Yeah, Gerard, maybe as you said, we can move to the next and we'll deal with Emilio afterwards. Yes.
Yeah, that'd be probably. Is Umut available? Oh, now you're back here.
Okay.
Can you hear me?
Emilio, yeah, if you have problem with internet, if you look below on the bottom right corner, you should be able to downgrade the quality of your...
Yeah, I can switch off the video.
Yeah, I'm sharing the screen again, and I'm going back to the... No, it's okay. Don't worry. Was this right?
Yeah,
Okay.
sure.
Yeah.
So Michael, focus on a competency question to validate and verify ontologies. And here the idea is that of using competency questions indeed in the form of, let's say, query to be sure that the ontology satisfies the requirements that are set at the very beginning of the ontology development process, which is something which Michael relates to methodologies similar to software engineering. Moving on to, there are a lot, of course, of, let's say, challenges here, but to be quick, no, I'm sorry, go back to the next, yeah, exactly. So concerning Walter Terkaitos, who works at the CNR, STIMA, he focused on how representing manufacturing knowledge and data, and Walter stressed the strong heterogeneity of data knowledge in this domain. So basically you have to deal with many different information, let's say modeling machines, capability, facility, events plan, and all sorts of things that you have in manufacturing domain. And this can be, of course, highly complex. And so Walter has been working for several years now on a model called an ontology called factory data module, which is a modular ontology, mainly based on an old version of IFC, so the industry foundation classes, different standards and different models used in engineering. And as Walter showed, the factory data model has been used across different projects for industry. It is implemented in 3D virtual environments where you can actually simulate some process going on in industry. And the last talk given by Mauro Dragoni, who was working at the Bruno Chiesel Foundation, Italy. He gave a talk about the SARF ontology, which is the Smart Application Reference Ontology. And here Mauro didn't really, let's say, focus that much on the ontology itself, let's say structures and so on, but more on the development process. And at least the lesson that I learned is that the SAREF has been developed in a bottom-up approach, being close to domain experts' requirements and needs. And this actually, according to Mauro, made SAREF a trustable ontology for industry, in the sense that because it was developed by communicating a lot with domain experts, then they feel it to be trustable with respect to their application needs. So there were several points of discussion during the final phases, let's say, of the session. And I mean, just to be brief about that, I think that one of the main issues discussed was that of ontology evaluation, indeed, which is something everyone is struggling with when developing ontology. And there is really a lot of space for doing research based on the material that has been presented during the talk. So I would recommend everyone to go back at the slides and the presentation that has been recorded. Thank you.
Thanks a lot. That's fantastic. And yeah, let's move on in the interest of time. We're a bit behind time anyway, then to Umut. So we're now coming basically to the two sessions that were related to the demonstrators, and so the first session was on the FAIR technology adoption demonstrator, and will be summarized by Muchan Simcek from University of Innsbruck.
Yeah, hi Gerhard, thank you. I think somebody needs to stop the screen sharing so I can share my screen. Yeah. All right, I hope everyone can hear me. I think we lost Gerhard somehow, but I'm hoping I'm not talking to the air. So our speakers, our session was about the adoption of FAIR principles in the demonstrators and also overall in the industry. And we had 3 speakers. Sorry, I forgot to change this title over there in the speaker section. Barbara Magania from GoFair, from Environmental Agency of Austria in cooperation with GoFair Foundation, and then who introduced FAIR principles briefly and also explained the activities of GoFair, focusing on the tooling support, particularly under development currently, to support implementation and evaluation of FAIR principles. And then we had a demonstration of FAIR adoption in a demonstrator of our own from Ontocommons project, and the presentation was given by Sebastian Schulze and Anna Correa from ATB Bremen, and they explained basically what they have done so far to adopt FAIR principles and what are the next steps. Basically, 2 dimensions were well implemented, and the next step is the remaining 2 dimensions, interoperability and reusability. And then Felipe Rocasera also gave a very comprehensive, insightful talk about the FAIR cookbook, which is, I think, a very powerful resource for anyone who wants to implement FAIR principles in their use cases, especially particularly in industry. This cookbook provides different ways of implementation of different FAIR principles, together with examples and what they're called recipes. And the cool thing about it is also the cookbook itself is also FAIR, so eating your own dog food motto. So the recipes are, for example, identified with persistent identifiers, provided some metadata, and so on. And after these very exciting talks, we had a discussion round. Of course, there were some small question answering in between. And then I tried to summarize the main points of the discussion. So the objective was actually of the session was providing introduction to the FAIR principles, demonstrating fair implementation and gaining insights about best practices and challenges of fair adoption. And I believe after the talks and the discussion, we achieved these objectives. What we have seen with the during the discussion is that also we kind of somehow managed to also fuse the main takeaways from different talks. So what we have seen is that usually there is no one-size-fits-all solution for fair adoption. So context is important. For example, we need to really define what is fair enough, right? So which dimensions make sense for which company or which use case. And although materials like, for example, fair cookbook are quite useful to and definitely necessary towards this direction, there is still a use case by use case interaction needed between companies who want to implement it and the people who are doing this fair, or they're experts in the fair principles, so to say, and community, not only individuals, but overall building a community towards this is very important. And fortunately, there is we've seen also as a gap, one of the main gaps in the fair adoption is that particularly after implementing the fair principles, the evaluation of it, because manual evaluation is not very scalable. And fortunately, as we found out from Barbara's talk, that tool support is coming towards this. So first of all, of course, it's called fair implementation profile. So to describe certain principles and the semantic assets in a machine understandable way. So making fair principles fair, so to say, and then provide some extent mechanized support for evaluating the fair adoption in a data set and metadata particularly. And we have also seen that fairness is also important for data and metadata usage within an organization, not only when sharing the data with the outside world, hashtag open data, or in other ways of interoperability between a company and the outsider, but also within an organization is also important. So this is also another incentive for advertising that for convincing policymakers to implement fair principle that this is necessary. So making data findable, accessible, and interoperable is also beneficial. There's an incentive for them also to improve the processes within the organization. And I think this also somehow was also discussed in the next section. Anna chaired afterwards, so was also kind of nice connection for that. I believe this is pretty much it for the summary from my side. And thanks again, everyone who made it possible. Jan Lefranc and for example, and our speakers, Barbara Filipe and Anna Correa and Sebastian Scholze. Yeah, that's all from our side. I think I had this muted or something's wrong.
Thank you very much. Yeah, thanks.
Yeah.
I also lost connection during your
ring,
but
anyway. I'm not sure if I was talking to the air or just.
Now we're back. Anyway, we're somehow dealing with the technicalities. But thanks a lot again for your overview of what looks like it's been a really great session, and you've given the segue to Anna's summary. So if she's on stage or coming on stage, then please go ahead with the summary of the demonstrator session. Yeah, hello.
Yeah, hi. So I will present the demonstrator session. I already got the notes from rapporteur, so I will just show them. So this is the session 5.2, the demonstrator session, and we had 3 talks there. One was from Bosch, from Evgeny Kharlamov. Then one was, so this was one manufacturing oriented. Another one was from Iker Esaniola from Technica, that was on Tribomat project. oriented on the more on use case on the border of say research and industry. And the third talk was by Jasper Kohorst from Wageningen University and Research in the Netherlands on FAIR data station for mapping metadata in life sciences. So the technology to how to adapt it in observation data in particular with the corresponding tool. So in the session, we basically wanted to hear about the experiences of various demonstrators and to come to see how well they adopt ontologies, where they have roadblocks, what are the important points which what we should pay attention to. So we had basically, well, the first talk was focusing on evaluation of construction of oil platforms, and some of the important things. Well, one of the takeaway was what we how we evaluate the impact of ontology adoption. So we had the discussion that one of important criteria, maybe the most important criteria, especially for manufacturing scenario, is time. And this is also, well, after adoption, how much time essentially do you save if you can do faster the same kind of things. And this is also a criteria understandable by everybody. And unlike to money, for example, because money is not so, well, it's even different from country to country. And we also had discussion here in this context that it's very good to have to convince actually, well, for example, decision makers to use ontologies. It's also good to give scenarios, very illustrative scenarios, and this is also maybe what we should do when we write, for example, roadmap, contribution and demonstrators. And some of such scenario can be, well, we had a discussion on two of them. One was integration of the data across the value chain, and which is a far-fetched scenarios for many companies, but at some point of time you have to do it. And the second one was on digital twins, because this is also what is comes into trend, and where ontologies are often adopted, that it's easy in many domains, really in from manufacturing to life sciences, it's material sciences, it's really easier often to say simulate something with digital twin, and you save again time and also various factors associated with it. It's also being green and being efficient, and number of other things. Then in the with the demonstrator from the FIBO project, then we also discussed various things. Well, for example, that this project had focus also on how to involve, say, end users, and this is we had a discussion that here that it's very good or very useful, well, in this case, but also in other ones. Other speakers also agreed to make ontology use invisible, at least for end users, that they well, don't really know that they are confronted with ontologies. And but for more advanced users, of course, you can have a more high level of complexity, and that they can interact with ontologies and understand that they are ontologies. Also, we had the question was if large companies benefit more by them, but or than small ones. But this is also depends here, because large companies are possibly more resilient, and they can maybe still survive. But for small companies, it's maybe really essential to adopt some new technologies because they maybe they would not survive, right? So this from this focus, is important. And from the third use case, we again, it was emphasized, which was about fair data production, especially for observational data, which is in life sciences, but also in scenarios, in engineering scenarios, for example, you get to this kind of data. And the tool was showcased, which we also broadly used in Wageningen to make Excel sheets in fair data. And there, of course, also we emphasized again was that we have this, it's very important that actually the data producer really sees value, preferably immediate value, to do this kind of data work. And for example, one of the values can be that you have all your own data structured in a good way, so you start to use this tool because you want to work yourself with your data in a more efficient way. But and then of course it can be also useful for others, but there clearly should be some immediate use, because well, people are mostly not motivated by helping others. Yeah, that I would not, or a user would not be typically spending a lot of time to make data useful for somebody when there is no motivation or reward for this activity, yeah, because it's also cost time. So this is also very important to take into account. And also the research projects and developments are quite can be also long-term and ongoing developments. So then there is following questions, and I think I mentioned. So basically, well, as a summary, of course, it's this is kind of the common line, and or for the benefits of the use, that if you have, for example, a big company like Google, yeah, and they say, well, we use schema.org, then of course people also start to use it. But it's in the domains where we address, actually, we also, it was observed that we don't have a kind of a central authority where we could just go and convince them to everybody to use ontologies. We don't have in our case this, unfortunately, so maybe we should be even looking at some methods to make scenarios which that the users are convinced that it brings something for them. So a kind of behavioral change approach. Yeah, so these are the main points of, or what discussion points of our session.
Thank you. Thanks to you and to all the speakers again today. And thanks to your participation, everyone who's joined us today. The workshop will continue tomorrow morning at 10 o'clock, and there will be a plenary presentation on enterprise knowledge graphs as a basis for company-led innovation by Katarina Newberg-Kari from Inter-IKEA Systems, followed by some more interesting sessions in parallel on use cases for innovative ontology applications and ontology engineering in material science. So looking forward to seeing you in the morning and rejoining the session at that time. In the meantime, as we discussed and said previously, you can also join now, after leaving the session, the lounge, where you can sit down at tables and have some more discussions there, or join the poster tables. Thank you very much.